Hello, you absolute legends. Cerebral spinal fluid is something that bathes the brain and the spinal column. Cerebral spinal fluid has high and low end healthy ranges for glucose. The low end range is 50 milligrams per milliliter, and the high end range is 80 milligrams per 100 milliliter. These therapeutic ranges in blue, it's need to be clear about what we're talking about when it's milligrams and milliliters. This 50 to 80 is talking about the glucose that's in the CSF, dissolved in the spinal fluid. And this is for every 100 milliliters of cerebral spinal fluid. We want to calculate the molarity of the low and high end ranges of healthy individuals. Molality is a terrible word because it doesn't tell you what the units are. Molality is moles per kilogram. And that's frankly just something you got to put in your memory banks or be able to Google it on a Jiffy because it's just a terrible name. So we want to have the moles of glucose per kilogram of CSF. I'm going to put a G and a CSF there just so we're clear about that. Now we need to have, so for this example, we're just going to calculate the low end, the 50 milligrams of glucose per 100 milliliters of CSF. And we want our units in moles per kilogram at the end of the day. So I want to start my scaffold with something that has moles of glucose or kilograms of CSF in the top or bottom right there. Now, the kilograms of CSF and milliliters of CSF, we're going to need the density at some point in this problem here. Spoiler alert. We're also going to need the molecular weight of glucose at some point in this problem here, because that's where we're going to dig this stuff up here. Grams, 1.00059 grams per milliliter is the density of CSF. Note that it's very close to water. It's effectively water with minerals, molecules, and vitamins dissolved in it right there. It is in grams per milliliter. We want kilograms. So I'm going to start this problem with grams in the bottom. 5.9. Now this may look odd, but remember, the units are driving me. Kilograms and grams are cousins of one another. So now I have kilograms of CSF in the denominator. That's exactly what I want. I need to get rid of this milliliters of CSF. Note that I look at my shopping list first. When I'm trying to find a unit, I look at my shopping list. Because we're solving for the low end, so I just did the low end numerator and the 100 milliliter denominator there. Boom, boom. Milligrams and moles. Milligrams and moles. The periodic table for every compound can give us the units or elements, grams divided by moles. Grams and milligrams. Glucose, I think, is 180.16 grams per mole. Now I understand that grams and milligrams don't cancel out right here, but I'm just going to put in a little conversion right here. For every 1 gram, there's 1,000 milligrams. So 2 from the 3-point line, milligrams cancels, and then inside, yes, I forgot to write the gram in there. That makes more sense. I've used everything in my shopping list. All the units cancel except for moles in the numerator of glucose and kilograms of CSF in the denominator. This scaffold method guided me to the answer without looking up a formula, by the units guiding me to make sure things cancel or convert as appropriate. I hope this helps. Thank you.